In this video, I am going to demonstrate how to create a power series for a function. So the function I'm going to start with is a very common function that we are all familiar with. F of x is equal to the sine of x. So we want to create a power series for this. And we're going to do it by creating a Taylor polynomial. And a specific type of a Taylor polynomial that is centered at 0, which is sometimes called a Maclaurin polynomial. And from that Taylor or Maclaurin polynomial, we're going to create a Taylor or Maclaurin series. And that series is a power series. So a Taylor polynomial is of the form, and P is for polynomial, f of a plus f prime of a times x minus a plus f double prime of a times x minus a squared over 2 factorial plus f triple prime of a, that would be the third derivative, x minus a to the third power over 3 factorial, on and on and on. And so this is what is called a Taylor polynomial. Now, if a happens to be 0, then it is a special type of Taylor polynomial called a Maclaurin polynomial. And from that polynomial, we can create a Taylor or Maclaurin series. So let's demonstrate how we would do that for the function sine of x. First of all, in order to create a Taylor polynomial, you need to be able to take an infinite number of derivatives. And we know that's possible with the sine of x. With the sine of x, we can take derivative, the derivative of the sine is cosine, the derivative of cosine is negative sine, and we can do that as an infinite number of derivatives. There's not many functions that have an infinite number of derivatives, but this is one of them. All right, so let's get started on doing that. So first of all, we have f of a is, or f of x, is the sine of x. And the first derivative, f prime of x, is equal to the cosine of x. F double prime of x is negative sine of x. F triple prime of x is negative cosine of x. And we can keep doing this. I'm just going to go one more. The fourth derivative is back to sine of x again. Well, now we want to find what f of a is. We want to evaluate this function. And so the sine of 0, as we know, the sine of 0 is 0. And so f prime of 0 is going to be 1. F double prime of 0 is 0. F triple prime of 0 is negative 1. F to the fourth of 0 is 0. And so this is going to alternate. If we were to go one more, f to the fifth of x is going to be back to cosine of x, and f to the fifth of 0 would be back to 1. All right, so these values of the derivatives give us basically what would sometimes be referred to as the coefficients of the Taylor polynomial. Now let's see how we put this together in the form of a Taylor polynomial. So again, the formula is we want to start with f of a, then we want to go the first derivative at a times x minus a, then we want the second derivative at a times x minus a squared divided by 2 factorial. And so let's just do those first 3 terms now. And so we know that f of a is 0. So f of a is 0. F prime of a is equal to 1. So we have 1 times x minus a, but a is 0, so that's just 1 times x. The second derivative is 0 again, and that doesn't give us too much. So we're probably going to want to go to the third derivative here, f triple prime of a times x minus a cubed over 3 factorial. Well, that is going to be, the third derivative is negative 1 times x minus a, which is just x. I'll just write that as just x, because a again is 0, cubed over 3 factorial. Now the next term is going to be a 0. And so we want to find a pattern here. If we just get rid of the zeros, the first term of our polynomial is x. The second term is minus x cubed over 3 factorial. And if we were to go to the next term, it's going to end up being x to the 5th over 5 factorial, and then another 0, and then a minus x to the 7th over 7th factorial, and then another 0, and then an x to the 9th over 9 factorial. And you could verify this by taking more derivatives and going and taking more and more terms to create this Maclaurin polynomial. So this is the polynomial. This is a polynomial, and of course these are just the first 5 terms. They go on and on and on. But this polynomial is an approximation of the sine function. What we want to do now is we want to create an actual series representation for this polynomial. So the sine of x is going to be equal to the sum from n equals 0 to infinity. And so this is the first term, second term, third term, fourth term, fifth term. And so we can see that there is kind of a pattern here. And the pattern is, first of all, we have alternating series. So we're going to have a negative 1 to the n power because we want to start with a positive term. And if you notice, this is the first power, third power, fifth power, seventh power, ninth power. Each term is increasing as an arithmetic sequence. And it just so happens that that arithmetic sequence is the 2n plus 1. And we're going to divide it by 2n plus 1 factorial. Now remember, you can tell that it's an arithmetic sequence because there is a constant difference between each two terms. There's a difference of 2. And so you can determine what the arithmetic sequence is. We gave a formula for finding arithmetic sequences back in the section 5.1. All right, this is what we would call the Taylor series, or more specifically, because it is centered at 0, the Maclaurin series for the sine of x. Now, whether you call it a Maclaurin series or a Taylor series, they are both power series. And so we can determine the interval of convergence for this particular series. I'm not going to do that in this video. Perhaps I'll do that in another video. But we would use the ratio test to determine the radius of convergence for sine of x. As it turns out, the radius of convergence is going to be infinity. So for all values of x centered around a equals 0, this converges. So this power series converges to the sine of x. In another video, I'm going to use Desmos, and I will actually demonstrate what we mean by converges to sine of x. But that is for another video. In this video, I just wanted to demonstrate how we can create a power series for a given function.